Hey all, welcome to the class, and this is Advait E, your chemistry teacher for sure. I am also your maths teacher, I'm also your social science teacher, I'm also your English teacher, I'm everything, guys. Okay, so our chapter today, both chapters, chapter matter in our surroundings and is matter around us pure. It's a very important chapter. I think you all will be able to follow the chapter. Matter in our surroundings. Only one equation in that chapter. I am already writing K is equal to C plus 273 degree, which is Kelvin to Celsius to Kelvin. That's the only thing you have to learn, and else than that everything is already in the lesson. Okay, so let me just some or the other issue is always with there with this board. Please wait a minute. Wait a minute. Wait, please wait. I'll share the entire screen because nothing is working out other than that. Let this be there. One second. Let me just adjust everything. Okay, now clear. Okay, sure, we will move on to the chapter matter in our surroundings and discuss what is matter. Matter is anything occupies space or mass. Mass is amount of substance. Yes. If this is a water bottle, inside that water is filled, then that is actually mass is occupied or space is occupied on the matter. So it exists in the form of 5 basic elements: the Panch Tattva. We always say the air, earth, fire, sky and water. For example, chair, bed, river, mountain, dog, tree, building, etc. Now, what are the characteristics of matter? We know that matter is actually made up of innumerable number of particles. Number of particles known as atoms. Matter is made up of innumerable number of particles known as atoms. Now, next, matter is constantly moving. Always kinetic energy. It's kinetic energy. Then we have matter have intermolecular space. Intermolecular space. For particles of matter attract each other. Innumerable number of particles attract each other. These examples also I'll give because matter is made up of small particles that KMnO4. You can use KMnO4, then 4 is actually written down. Then matter is constantly moving, diffusion. Matter have intermolecular space, salt in water. Matter attract each other. You can give an example on your own. So that are the characteristics. Now we are talking about diffusion. Diffusion is actually particles of the matter intermix on their own. Particles of matter intermix on their own. Okay. Particles of matter intermix on their own. So they do so by getting into spaces between the particles. This intermixing of particles of two different types of matter is known as diffusion. So they do so by getting into the space between the particles. PS. I am writing this PS. They intermix of particles. I am writing very badly. Sorry, I didn't look at the screen. I was just keeping on writing. So they intermix each other. This. They mix each other. They just okay. Now mix and diffusion. I think we will have a different meaning of word diffusion. Diffusion means like when a mixture gets from it's moving from a area of lower concentration, higher concentration to lower concentration due to random kinetic energy and particle movement. Okay. Now applications of diffusion: dissolving solid in liquid. So when a crystal of potassium permanganate KMnO4 is placed in a beaker, the water slowly turns purple into it on its own without even stirring, because the both KMnO4 crystal and water are made up of tiny particles. Tiny particles have kinetic energy. They mix on their own. That is the reason. Then mixing of two gases. Agarbatti is a very good example for that, because agarbatti lightened in the corner of room, it's actually spreading like this. Its aroma spreads very quickly. Area of low from higher to lower, right? Higher to lower. lower. Higher to lower. Brownian motion of particles by Robert Brown. The random zigzag. The random zigzag movement of microscopic, I'm writing MS, particles, PS, in a fluid, as a result of continuous bombardment. As a result of continuous bombardment. Hearing this word, actually it's very nice, because in 9th standard these tough words are right. Some like theta and all is there, angular velocity in 9th I think, physics. So it's very cool to see this name, bombardment from molecules of the surrounding medium is known as Brownian zigzag moment in the bombardment of the matter. Basis of classification of matter, they are upon particle arrangement, energy particles based upon distance between particles. Now the three states of matter. There are three states of matter, as we know: solid, liquid and gas. Solid actually is very closely packed, liquid is less closely packed, and gas are packed very differently. Force of attraction between particles are strong, is relatively not that less, and here it is negligible. Negligible it turned out. It's not my usual board, so I'm not that into this writing. Just stylus. I'll just take another. Can't we take another? I'll take in black. This is more good, right? I like this more. This black. Okay, so this is the force of attraction is strong. They have definite shape and volume. Here they do not have. Then density there. Here it is incompressible. It is almost compressible. Only 4 marks questions only come for this. If you get 5 marks, write according to it. This is solid. Tightly packed, right? Solid. Then liquid is in a beaker. It's not that tightly packed. I never see liquid tightly packed. But carbonated, yes, carbonated is often tightly packed. This is gas. It's actually not a beaker, it's a gas container. But when I drew it, it's like bad. It usually is, right? Then it is dots. Gas is very loosely packed. They have distance, like very high distance. That's it for that topic. Let's move on. Temperature and common SI units. The temperature is, we have the common unit is CU. CU is Celsius and is Kelvin. C is Celsius and here it is Kelvin. And 0 degrees Celsius is equal to 273 Kelvin. It's Change of state of matter. By changing the temperature, by changing the pressure, we can change the state of matter. And what is melting? Melting is actually changing the solid substance liquid ആക്കുന്നത്, solid to liquid, liquid to gas, and solid to gas. We have many things to learn. If I will show you using a triangular concept, very important. Liquid, gas, and solid. Here, solid to liquid is known as fusion, and liquid to solid is known as solidification. And liquid gas and gas to this is the both. So liquid to gas, we know it's vaporization, and it is here it's condensation. Then this solid to gas, I think it's sublimation. Both are sublimation, right? Both are sublimation. Both are sublimation, but you can say this gas to solid, you can all say gas to solid, you can say it is deposition too. Always draw this triangular thing. Fusion is actually solid to liquid, and liquid to solid is solidification or icing or freezing and all. So melting is the change of solid substance into liquid. Then melting point is the temperature at which solid melts to become a liquid at atmospheric pressure. And liquid to gas, it's known as boiling. Boiling point we have to learn. Boiling point, the temperature which a liquid boils at and changes rapidly into gas at the atmospheric pressure is known as boiling point. That is liquid to gas. And gas to liquid, is condensation. That is on cooling. Liquid to solid, lowering temperature, freezing and in a freezing point. Fusion is change of solid state into liquid state is also known as fusion. Freezing and fusion ഒന്നാണ് ഞാൻ പറഞ്ഞു. Sorry, solid to liquid അല്ലേ? Liquid to solid ആണ് fusion അല്ല, solidification. Now latent heat of fusion is actually latent heat എന്ന് പറഞ്ഞാൽ എന്താ? The heat energy required to change the state of substance without causing any rise in the temperature of the substance is called latent heat. But latent heat of fusion the heat energy required to convert 1 kilogram of solid into liquid at atmospheric pressure. 1 kilogram of solid into liquid at atmospheric pressure. It is known as latent heat of fusion. Latent heat of evaporation is the heat energy required to convert 1 kilogram of liquid into gas at atmospheric pressure at its boiling point is known as latent heat of vaporization. Sublimation we learned, it is a state of gas to from a solid to gas or gas to solid. Sublimation, we can say deposition from gas to solid also. Evaporation is a surface phenomena